In this video, I'm going to show you how to balance equations. So let's look at this worksheet that we did in class. It says atoms are not blank or blank. That is gained or lost during a chemical reaction. Scientists note that there must be the same number of atoms on each side of the equation. To balance the chemical equation, you must add coefficients, and that's those big numbers, in front of the chemical formulas in the equation. You cannot add or remove the subscripts, and that's a pretty important point. So this is an example of a subscript. See that little 2 with oxygen? And you cannot mess with those. Nor could you add a little 2 right here, or any number right in here for the magnesium. You can't add a little number right there for that magnesium. You can't do anything to these subscripts. They've got to stay the same. The reason for that is, it might seem nitpicky, like why can't you? It seems like you ought to be able to. When you can add all the big numbers you want over here, you can add 2s and 4s and 6s and stuff like that. You can change those numbers all you want, so why can't you change the little numbers? Well, it's because the little numbers determine what chemical it actually is. So, for instance, this chemical right here, H2O, is water. But if you change one of the subscripts, H2O2, that becomes a different chemical entirely. That's hydrogen peroxide. So, I will just give you one example of why that's a big deal. So if you drink, let's say a half gallon or so of this, that's perfectly fine. It keeps you alive. You have to drink to stay alive. But if you drank, say, a half gallon of this hydrogen peroxide, it would quite possibly kill you. So those two things are not at all the same. And what was the difference? Just one tiny little subscript right here. Similarly, you have carbon monoxide, and you have carbon dioxide, and those are different chemicals as well, right? So you've got to remember, the subscript itself cannot be changed, because if you do that, you change the entire chemical that you're working with. And these problems are not about changing chemicals. These problems are about balancing the chemicals that are already there. Okay, so enough on that. Let's look at the rules. So number 1, you determine the number of atoms for each element. Let's look at this as an example. And you think about both sides independently. So here is the reactant side. Here is the product side. So here on the reactant side, how many magnesiums do you have currently? Well, there's 1 magnesium there, and there are 2 oxygens here. Okay? And what about on the product side? Well, there's 1 magnesium there, and there's 1 oxygen right there. Okay? Now, number 2 says, pick an element that is not equal on both sides of the equation. The one that jumps out here is oxygen. There's 2 oxygens on the reactant side and only 1 on the product side. Okay? Next, 3. Add a coefficient in front of the formula with that element, in our case oxygen, and adjust your counts. What it means by your counts is these things down here where you have counted how many atoms are on each side. You've got to make a list for each side, and it helps to keep the list in the same order. So like magnesium, if it's first in your list for the reactant side, make it first in the list of the product side. Now here it's already been done for us, but in your problems you'll have to actually write out magnesium and then the number, oxygen and the number, and then write it again over here underneath the product side. So you have to make your list, and it's very important that you do that. Otherwise you increase your chances dramatically of getting the problem wrong. So what did it say to do here? Add a coefficient. Remember, that's those large numbers in front of the formula with that element. So where is the one that we're interested in? You have 2 oxygens already from the little number 2, and we can't really change that. So if we put a coefficient over here, like let's say 4, we would only be making more oxygens in the side that's already imbalanced by having too many. So this, if we did that, that would make not 2, but 4 times 2 is 8. There would be 8 oxygens there. And see, it's even more unbalanced now. So we don't want to do that. Let's go back to how it was. By the way, you should always do these problems with a pencil and an eraser so that you can erase things and change things like this, okay? So here we're going to change this side, the product side. Now how do we do that? We have to find where the oxygen is. In this case it's right here. And remember, don't put a little t right there. As tempting as that may be, you got to use a coefficient. So how are we going to do that? You have to think, what times 1, or whatever number you happen to have there, what times that number would get you equal to this number over here? So obviously 2 times 1 would be equal to 2. So I put a 2 as the coefficient. Okay. Now it says adjust your counts. Okay. So instead of 1 oxygen over here, now we have 2 oxygens. So you remember that large 2 multiplies everything across the whole compound by itself. But you know what that means? Not only have we changed it to where there's 2 oxygens, we've also made there be 2 magnesiums. So here's where that pencil with the eraser comes in handy. Adjust your counts. Got to be careful to adjust everything that is affected by your coefficients. Okay, so now these 2 are equal. That's good. But look at this. In the process of doing that, we have unbalanced the magnesiums. So how can we fix that? Well, go back over here onto the reactant side. Don't put a little 2 here. You got to put a big 2 over here. And what has that done? Well, it multiplies everything in that compound by itself. So now there are 2 magnesiums. Does it also reach all the way over here to the oxygen? No, because that's separate from the magnesium. So here, all it really affected was that one single magnesium. Okay, so now the magnesiums are also balanced. Check. Okay, and if you want to put a number here, you can leave it blank, or you can put a number 1, either way. So we could say that the coefficients that balance this equation are 2, and then 1, and then 2. And then you can double check. It's always a good idea to go back and double check and read through the whole equation and make sure that the numbers are the same. So let's see, we have 2 magnesiums here. Okay, 2 magnesiums. We've got 1 times 2 is 2 oxygens here. Okay, so 2 oxygens, that's all right. What about this? We've got 2 magnesiums and 2 oxygens. Okay, so that's right as well. Good, it looks like that problem is balanced.